solve cotangent x minus radical 3 equals cosecant x over the interval 0 to 2 pi. In this problem, you should recognize that they're not the same trig function. Put your finger on an identity that has both cotangent and cosecant. What do you have to use?
1 plus cotangent squared plus cosecant squared.
So that's the Pythagorean identity. But you recognize that this problem, on each side, there is not the power of 2. So what are you going to do? We're going to have to square both sides. I like to draw a line down my equation, separate both left and right side. I like writing the problem again so that I have the original problem to look at and it's not marked up. We're going to go ahead and square both sides. That means on this side I'm going to have cosecant squared x. Over here, this is essentially cotangent x minus radical 3, but you have to write it twice because of the power of 2. Now the common mistake is to make this cotangent squared x and then minus 3. That is incorrect because it's a binomial, so essentially you're going to have to FOIL or use the box, which I'm going to show you. So if I use the box, you'll notice more and more that we're doing a lot of more side problems that help you with the basic algebra to see how it's connected to our problem. I have cotangent x minus radical 3, cotangent x minus radical 3. Let's go ahead and multiply. Class cotangent times cotangent. Cotangent x times negative radical 3. Negative radical 3 cotangent x. Remember, back in Algebra 2, you would have written the irrational number in front. Okay, and you usually write the variable in the back. This is the same, negative radical 3 times cotangent x. And then negative times negative is a, and radical 3 times radical 3 is radical 9, which is alright, so now I'm just going to combine like terms. I have cotangent squared x here. This is a negative radical 3 x and a negative radical 3x, and your coefficient here is a 1. So think of it, it's like negative 1x minus 1x. Here, this is going to give us a negative 2 radical 3. So pay attention. There is no 2. I got that from the negative 1 and the negative 1. That gives me negative 2. Radical 3 cotangent x plus 3 equals cosecant squared x. Now this cosecant squared x we just did above. We did the quotient Pythagorean identity. Every time I see cosecant squared x, I can write 1 plus cotangent squared. Class, what am I going to write here in yellow? 1 plus cotangent squared. Alright, this is a quadratic linear, so I'm going to move all of this to the left side and set it equal to 0. So I'm going to subtract 1, and I'm also going to subtract a cotangent squared x. You should recognize that these cancel. I'm left with a negative 2 radical 3. Oh, I should have left it on the other side. That's a plus 2. I'm recognizing that I'm trying to solve for x, so I should have left that negative 1 on that side. So let's move over that negative 2. Class, what do I have left? Equals a negative 2. Alright, so in this problem, now I'm trying to solve for x. So I'm going to divide both sides by negative 2 radical 3. These will cancel. Cotangent of x equals, on this side, think about it for a second. Let me pose a question. You'll show me your thumbs. The answer is 1 over radical 3. Show with your thumbs. So the common mistake is I saw a student cross these off and they realized that they have radical 3 left, so they wrote radical 3. That would be incorrect. The radical 3 is in the denominator. Remember, if you need help with that, write them out as factors. So negative 2 can be written as negative 1 times 2. Negative 1 times 2. I should have just done negative 2, huh? Negative 2 times 1. Try that again. Negative 2. Negative 2 times 1. So it's so that when you cancel out those negative 2's, you realize there's still a 1 left in the numerator. So your answer is 1 over radical 3. Now this is helpful for us. So I'm just going to highlight it and I'll show you why in a second. The reason why this is helpful is if I take the inverse, notice how I didn't rationalize. So now we're left with the inverse of cotangent of 1 over radical 3 equals x. And let me explain why I did not rationalize. The reason why I'm not rationalizing, because when I rationalize, that's when my goal is to simplify a problem. The reason why I did not rationalize here is because I need to go to my unit circle. If I go to my unit circle and I get a rationalized part, there is no y value that's equal to 3 on the unit circle. Are you following me? Yeah. So here, I have an x over a y. I can find that. So put your finger on where cotangent is positive. Now I'm looking for a x value of 1 and a y value of radical 3. Where is that?
16
Pi over 3, because I'm looking for radians, and 4 pi over 3, because this is a negative 1 over a negative radical 3, which is a positive. Remember, you can ignore the 2's because we don't need the r value, right? Okay, so we said, what was the answers? Okay, we just finished the 2/3 of the problem. Now, we normally think that this is the answer. X equals radic pi over 3 and 4 pi over 3. Okay? But I'm just going to put a star here. Check. Solutions. When squaring, square both sides. In this problem, in the very beginning, we squared both sides, and this changes what's actually happening. So what we have to do is we have to actually check our solutions. Back in Algebra 2 or your Math 5 class, you may have learned about extraneous solutions. So what we're basically going to do is we're going to test pi over 3 And we're also going to test 4 pi over 3. Well, what do I test it with? I have to take this blue and put it back into the original equation. So let's check our answer here. So I'm just going to write the original problem. Cotangent x minus radical 3 equals cosecant x. Write it again. I'm going to go ahead and do the blue one first. I'm just going to substitute in pi over 3, which we just found is one of our possible solutions. And when you're testing a solution, it's a question mark. We're not sure if they're actually equal. Okay, so let's go ahead and find cotangent of pi over 3. Here's pi over 3. Cotangent is x over y, so that would be 1 over radical 3. This is radical 3 over 1. And at the same location, I'm going to find cosecant. Cosecant is which two letters? So that's essentially the sine, reciprocal of sine. Would you agree?
Yeah.
So if I find sine at pi over 3, all I have to do is just take the reciprocal, which is what? 2 over radical 3. So now I'm just going to go ahead and simplify these and see if it's equal or not. I'm going to rationalize here. Multiply across 2 radical 3 over 3. Over here I'm going to rationalize. Multiply across, what do I get? Over here I need a denominator of 3, so I'm going to multiply by 3 over 3. So that gives me 3 radical 3 over 3. Here this has a coefficient of 1. These are like terms. 1 minus 3 is what? Negative 2 radical 3 over 3. And this side I have a positive. Class, are those equal?
No.
So we're going to say not equal. Alright, so now we're testing the last one. We're testing 4 pi over 3. So cotangent of 4 pi over 3 minus radical 3 cosecant 4 pi over 3. I'm going to use my unit circle at cotangent at 4 pi over 3. So 1, 2, 3, 4. What are we looking for? 4 pi over 3. 1, 2, 3, 4, 5, 6, 7 pi over 6, and 8 pi over 6. Yes? And I'm looking for cotangent, which means x over y. So this would be a positive 1 over radical 3. Minus radical 3. At the same location, we're going to be finding cosecant. Cosecant is just reciprocal of sine, so that's going to be what? R over y. So here, if I look at sine, and I take the reciprocal, it's going to be what? Negative 2 over radical 3, right? And then I just need to simplify. So here I'll rationalize. Here I'm going to multiply by 3. Remember, the 3 that I'm multiplying does not go inside the radical, so that would be a minus 3 radical 3 over 3. and we are testing this if it's equal to a negative 2 radical 3 over 3. Remember, there's a 1 right here, so 1 minus 3 is negative 2 radical 3 over 3, and that is equal to a negative 2 radical 3 over 3. Raise your hand if you got that. What does that mean? That means that 4 pi over 3 is actually our solution, and pi over 3 is an extraneous, which basically means although we found it for x equals, it actually doesn't work. So x is equal to 4 pi over 3. This is the only one that actually makes the equation true. So what do? Get an identity that connects the two of them. If it's quadratic, set it equal to 0. In our case it does. Zero product rule. Test your answers, and the ones that are equal, that's our final answer.